So problem 8. In this problem, we're given a piece of equipment called an Atwood machine. So this is basically just a pulley with two ropes with masses hanging off it. And this mass here, mass 1, is 2.0 kilograms, and this mass here, mass 2, is 3.0 kilograms. And in part A of the question, we're asked to write an expression for the net force on the 2 kilogram mass. It's got a tension T, and we need to take into account the weight force as well. And so in order to do this, we know that the net force from Newton's second law is equal to the mass times the acceleration. So we can write this as m1a, if we call this one here m1 and this one here m2, is equal to, now the tension is pulling it up and the weight force is pulling it down. So those are acting in opposite directions, and we need to subtract them from each other. So we've got the tension minus the weight force. So this is the expression here. Now if we want, we can substitute in m1, we know is 2.0. We don't know what the tension is, but then we've got 2.0 times 9.8. So that is the answer to A. Part B says, write a similar expression for the net force on the 3 kilogram mass. So this 3 kilogram mass has the tension pulling it upwards and its weight force pulling it downwards. So the result of these two forces acting on it is going to be the acceleration of this mass. So in this case, we've got the weight force pulling it down and the tension pulling it up. And so we can substitute in the 3 kilograms. So we've got 3.0a is equal to 3.0 times 9.8 minus t. And then finally, part C says solve these equations simultaneously to calculate the acceleration of the two masses. So let's call this one equation A and this one equation B. If we add these two equations together, then we have a tension here and a negative tension here, so these are just going to cancel out. So we can add the left-hand side, so we've got 2.0a plus 3.0a, and we add the right-hand side. So we've got 3.0 times 9.8 minus 2.0 times 9.8, and then we've got plus t minus t, and that cancels out, which is why I haven't written down a t here. So we've got 5.0a is equal to, can take 9.8 out as a common factor, and we've got 3 minus 2, which is just 1. So this is 9.8, and so the acceleration is just equal to 9.8 on 5, which when we solve it on the calculator, or you can do it in your head, we get 1.96, except that we only want it to two significant figures, so this is 2.0 meters per second per second. So we've now solved that problem. You could have a go at working out what the tension is as well, because that is something else that could be asked.